Math. When you hear that word, what questions come to mind? Why is math so hard? When will I ever use this? Is math really so important? To answer your questions, we are bringing math from the classroom to your room with Professor Jeffrey Ingram. Welcome to Ingrammatics.
Good evening. My name is Professor Jeffrey Ingram. I'm assistant professor, instructor of mathematics and engineering. I've been teaching for over 20 years now. I have a background in mathematics and engineering. This is the second time we've aired Ingrammatics. Real quick, Ingrammatics is basically help athletes. If you guys go to the league early, we want to help you finish your degree if you're interested. In addition to that, we have actuary finances. If you want somebody to look over your contract, if your first contract, make sure everything looks good. We just cater to athletes. I'm pretty sure we have something for you to benefit for. So please follow me on Instagram, Facebook. You can call also. These are good resources. But real quick, I'd like to say congratulations to Fayetteville State University for winning the CIAA championship this year. And wish you guys the best next season. Maybe you can run it back and do it again, but the Fayetteville State community is happy for you guys. So good job. Tonight, when we're looking at these sets, we have a little lecture on sets in which we're going to look at multiplication principle. All right, and then we're going to look at some factorials. Also, we're going to look at the mean, the mode, the standard deviation. All right, so we'll talk about this tonight also. So tonight, let's go ahead and get down to business here. First thing we're going to look at is the set. For a set is just capital letters. When you're given a set, let's say you're given set A. You're given A, B, C, and D. Just make a note that inside of a set, there are elements. So note that you have A, B, C, and D. These are elements. All right. So special notations that you guys need to get familiar with. We want to look at a union. All right. So for a union is basically look like a horseshoe. What you need to make a note, you need to list all. We're going to look at a Venn diagram. For this Venn diagram, you have find A union B. Inside of this Venn diagram, you need to list everything. Don't leave nothing out inside of A and B. You have some key words. The key word for a union is or. All right. Next, what we have is, let's say number 2. Let's go here. All right, so for number 2, let's look at the intersection. All right, for the intersection, this will be basically what they have in common. On the Venn diagram, it'll look like this. It'll say find A intercept B. And then on the Venn, you guys need to make sure that you look in the same spot. The spot that you need to focus on is right here in the middle. That represents the intersection. Also, we want to look at a disjoint. All right, so for a disjoint, This is also called mutually exclusive. So you got A and you have B. All right. And then next we have I guess we'll go with 3 here. This is the complement. All right, so for the complement, it'll be denoted as one of these 3 for the most part. You get A with a bar, you get A with a C, and you'll get A with a little tick mark here. All right? So looking at the next example, we want to say you're given a universal set like A, B, C, D, E, F, G, and H. Inside of set A, we'll do A, B, D, F. Inside of B, we'll do C, D, E, G. And then for C, let's do B, let's go with E, F, G, and H. What we want to do is we want to find the following. All right, we want to find A union B. We want to find A intercept B. And then let's look at find A complement. All right, so first thing we want to look at A and B. We want to see what A and B have in common. I'm sorry, we'll do A and B. List everything in A and B. So we're going to do everything. So don't leave anything out of A and B. So we're going to do A. I might have to start writing on the side over there. All right, so let's come over here. So let's follow so therefore, for A union B, we're going to list everything inside of A and B. So we're going to do A. We got B, C, A, B, C, D. Got E, F, and we have G. All right, make sure we didn't leave anything out. So we got A, B, C, D, E, F, and G. All right, now for the next one, they want you to find the intersection. That means common. So let's look at A and B. What do they have in common? Right now, we don't see anything. Well, we have a D in common. All right, so they have D. Also, make a note that, let's just say that they don't have anything in common. You need to put empty set, or this is a null set, empty set. If you guys go out and don't want to leave a tip, just put that on the tip. All right, now, the complement for A, basically what you're doing, you have to look at the universe and that set to find the complement. So what you need to do is basically is everything that they don't have in common. So we have A, we have B, we have a D, and we have F. So we want the complement where the complement will be C. So we got A complement equals 2. All right, so we got, all right, so what's left? C, E, C, E, C, E, G, and H. So this is the complement. One more. Let's do B complement. So let's look and see what B complement is. So right now we're going to look at the universe, and we're going to look at B. But we want what they don't have in common. So right now they have a C, a D, C, D, E, and G in common. So that means that the complement for B is going to be A, B, F, and H. All right. So quick little example. Let's find out what's the let's find out what's A complement intercept B complement. So we know this is the intersections. That means that you're going to look at these two. Do they have anything in common? Right now, looking at it, all right, C, no C, no E, no G, no, oh, we got an H. All right, so therefore, they have an H in common. All right? So moving forward, what we want to look at now, we want to look at the, well, let's just make another note here. Note that we have the probability. This is A. All right, so basically how this is read is the probability that A, given that B has occurred. So these are events. So basically it's like flipping a coin, lottery tickets, probability. If you're given this notation, you're going to have to do the probability of A intercept B. Whatever this is, goes on the bottom. This is the probability of B. Next, if you're given the probability A, let's do B. So let's say B, given that A has occurred. All right, so it's the probability A intercept B. And then whatever's here, go on the bottom. In a few minutes, we're going to look at some examples where we're looking at something like the probability of people that drink caffeine before taking an exam. What's the probability of you winning the lottery, things of that nature, all right? So also, we have the probability of A union B. This is the probability of A plus the probability of B minus the probability of A intercept B. And then just make a note to yourself that this is the probability of a sample space. This equals to 1. So in statistics, you want 100. So that it has to equal to 1. All right. And we'll do 1 minus the probability of A equals to the probability of A complement. All right. And then just keep in mind that this can rotate around because it comes from here, which equals to 1. So at this point, if you're trying to find this, you just subtract that over to the other side or vice versa, all right? Also, let's see what we have here. All right, so all right, and then please keep in mind that love for you to subscribe, so when you get a chance, hit that button at the bottom, please. All right, now looking at this next example, let's say that you're given a factorial. All right, so for factorial, this is denoted as a factorial. Make a note that you have 0 factorial, 1. 1 factorial, 1. 2 factorial is 2. 3 factorial is 6. 3 times 2 times 1. 4 factorial, that's 24. Also, where we're going to go with this, with the probability, we're going to look at basically how many ways can you arrange the lottery? How many numbers can you arrange in the lottery for the most part? How many ways can the numbers come out? That's going to be dealing with a permutation and a combination. So for the permutation, let's go here. For the permutation, you need to make sure that you note that the order matters for permutation. Your formula for permutation, we're going to do P N R. This is going to be P N R. This is N factorial, N minus R factorial. A combination, the order does not matter for a combination. The order, not important. Order does not matter for the most part. All right, so for your formula for a combination, we're going to do C N R. This is going to be combination N R. This is N factorial, R factorial, N minus R factorial. All right, so now looking at an example, let's say that you have, let's say find 5 factorial over 3 factorial. 5, 4, 3, 2, 1. 3, 2, 1. Cancel, 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 cancel. You should come out with 20. Using the calculator, so let's say that we have the TI 8384 calculator. So for the first example, let's say we want to find the combination of 5 and 3. For B, we want to find the permutation of 7 and 4. All right, so first you want to do, in the calculator, you're going to do 5. You're going to do math. You're going to do the probability, which is, you'll see PRB. You need to go down to N. You need to do P, N, R. And then you need to do your 3, and then you need to hit enter for a, let's change this to a combination, C, N, R. All right, and then for permutation is 7. This is math. This is PRB. You need to find the P, N, R, and then you need to hit enter 4 on the calculator. All right, so looking at what we have for the first one, we're going to do 5. We have math, PRB, probability. We're going to go down to number 3, and then we're going to enter 3. There should be 10. The next one, we're going to do 7. Math, PRB. We have number 3, 4, enter, 35. All right, so let's look at this one real quick. Let me check this one. 5, math, PRB, and that's a combination, which is 3. All right, so then that's 3. All right, yeah, so that's 10. All right, and then for permutation 7, math, PRB, permutation is number 2. All right, number 2, and we have 4, enter. All right, so let's check. This should be 840. All right, so we got 7 math, PRB, and that's a permutation. All right, enter, and then 4, enter. All right, good, 840. All right, so a good example, let's see if we got an example of a permutation and combination here. All right, let's see here. Let's do, all right, so let's see what we have here. All right, so for this first example, all right, let's do some pictures here. So we want to look at a gallery wall. And then we want to do in position. We want to put the pictures in order 1, 2, 3, and 4. And we want to ask how many ways. All right, how many ways can this be done? All right, and then for example number 2, let's do, let's play some poker here. So let's do 5-card hand. All right, 5-card hand drawn from a deck. All right, 52 cards. We're going to say 52 playing cards. All right, so looking at the first example, we're looking at a painting in which they want you to put in order. So this is definitely a permutation. All right, so looking at what we have, they're going to say that this is the highlight of the problem. They're going to say 9 paintings. All right, 9 paintings for all right, 4 are to be selected. All right, so we're going to say to hang. All right, so the first example, what we're going to do, we know that this is order, this is a permutation. Right now, when you're playing cards, the order really doesn't matter playing cards. So this is a combination. The big number goes first, so this is going to be 9, and then this is 4. Here, the big number goes first, so therefore this will be 52 and 5. Once again, you guys should know how to use the calculator. We're going to do 9. We're going to do math, PRB. When you do PRB, you need to find the notation of, we're going to do NPR. All right, so once you do that, you enter 4. All right, for this example here, for the permutation, you should get 3029, 3024. For the next combination, we had 52 playing cards. All right, and then for this one, this should be all right, so that's what we're going to get for these two. All right. And then real quick before we end, I want to look at the a little intro to statistics. All right, so we want to look at we have the S of X. This is your sample standard deviation. All right, and then we have this is your population, standard deviation. All right. Also, what we're going to look at is your X bar. This is your sample mean. This is mu. This is your population mean. All right. And then going forward with this, real quick, if you need to find this in the calculator, you need to do, you need to hit stat. Once you hit stat, you need to go to edit. Once you get here, you're going to have 2 columns. It's going to be L1 and L2. If you have a data set, make sure that you enter everything into the first column. Once you do that, the 4th step, you need to hit stat. For 5, you need to go to calculate. When you go to calculate, you want to do a 1 var statistic. Some of you guys might have to go down to calculate again and highlight it, and then you're going to have to hit enter. And then once you get then, you'll see your sample standard deviation. This is S to the second. This is your sample variance. All right, so I'm going to find the range. All right, for the range, this is the max number minus the minimum number. We want to find the mid mid-range, which is the max plus the minimum number over 2. We want to look at the IQR. Your IQR is your interquartile range, which is Q3 minus Q1. This is your semi-inner quartile range. This is Q3 minus Q1. This is over 2. Your 5-number summary, that's your box and whisker plot. For your box and whisker plot, we have this. This is the minimum number, which will be 4. This is your max. This is Q1, quartile 1, that's 25%. This is your median. Your median is 50%. Your Q3, that's 75%. Also, we want to look at if the mean equals to the median equals to the mode, this means that your data is symmetric. This graph means symmetric. All right. To find the median, all right, let's see here. So to find the median, you have 2 sets. You have an odd set. All right, you have 4, 5, 6, 7, and 8. 1, 2, 3, 4. 1, 2, 3, 4, 5. All right, odd set here, 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 here. That's the median. You have an even set. For the even set, 4, 5, 6, 7. So you'll cancel. It'll be 11 divided by 2. And then whatever you get for that. All right. So overview real quick. This is the introduction of basically your standard deviation, your sample variance, your range, your median. And I believe next time when we come back, we can cover the rest of this going forward with a little linear regression. So thank you for joining tonight. Please join again next week, same time, same place. Please subscribe. My name is Jeffrey Ingram again. Thank you, and have a good night.
Thank you for watching Ingrammatics with Professor Jeffrey Ingram. If you have any questions, you can write him at Post Office Box 33301, Charlotte, North Carolina 28233. You can call 910-710-6991 or reach out via email or Facebook. Thanks for watching, and see you next time.